and let's tell you what's going on. We're on our last chapter. I've reduced it so that we can get it covered for today, hopefully covered for today, and it will be part of your test. So we're looking at what is motion in space. So we've got your space curve, and it's traveling along in the direction that this arrow is pointing. And we are going to find, in particular, these things. We're going to find the velocity vector, which is very often called capital V of t. We're going to find the acceleration vector, very often called little a of t. And we are going to find speed, which tends to be called, well, I'll tell you its label without giving it away. So I want you to imagine, I like the roller coaster analogy, it works quite well with these questions. If you pick a point on the roller coaster there, and you imagine the derivative vector, that blue line, excuse me, I'm just going to mute some people, we're getting background sounds. Right. So I was saying, at that point there, the first derivative is your velocity vector. That's essentially, it tells you two things. It tells you the direction that you're going to shoot off to your death, but the length of that vector is how fast you're going. So there are two distinctly different things here that if you're not into physics, you tend to conflate and think they mean the same. Velocity is a vector. It has a direction to it. Speed is a scalar. So the length of the velocity vector is the speed that you're going. So you imagine this pen represents the direction you're about to shoot off to your death at. A big long pen means you're shooting off to your death at 80 miles an hour. A tiny little one, you're shooting off to your death at 10 miles an hour. So the length of the vector, right, the length of the velocity vector is speed. And because that's a length, do you see that speed is a scalar? Now, in the kind of physics that you've probably done, they should have distinguished between velocity and speed. I'm traveling 50 miles an hour is a speed. I'm traveling 50 miles an hour north is a velocity. You see there's a direction associated with it. I'm traveling 20 miles an hour upwards or 20 miles an hour downwards. Those are considered velocity because they have a direction associated with it, right? Speed, on the other hand, doesn't have any direction. I'm just traveling whatever way I happen to be going at a certain speed. Now, if the velocity vector is the first derivative, what do you think the acceleration vector is?
Second derivative.
Right. Now, doesn't that follow really very closely with what you did in Calc 1? So let me remind you Calc 1. You remember there might be a position vector. You know, it looks like that, right? Wasn't the velocity the derivative? And wasn't the acceleration the second derivative? Can you remember doing those things? Well, if you think about it, that's like your position function, right? That's like your S of t, but it's not a vector, right? Velocity vector, acceleration vector, right? So, application of it is actually quite easy. Aren't you basically going to find first derivative, second derivative, and the length of that vector? And that's the type of questions that you're going to be asked at the beginning. So here is a space curve, a t squared plus t, t squared minus t cubed, and a 2t squared. I'm just making up one randomly. I want to find its velocity vector. I just find the first derivative, which is 2t plus 1, 2t minus 3t squared, 4t. And I want to find the acceleration, vector. And what's that going to be? 2. 2t could be 6t and 4. And I want to find the speed. So I find the magnitude. So that one's probably going to be the ugliest one to do. And the magnitude of this vector is first guy squared, second guy squared, last guy squared. And I'm just going to dot, dot, dot that. But you can imagine what you'd need to do here. When you have to FOIL, 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 and collect like terms, and you get a big ugly polynomial. That's pretty much it so far. So if I gave you a space curve, would you feel comfortable about finding velocity, acceleration, and speed? Yeah, okay. Let's do another space curve. Let's do a helix, because they tend to come out in nicer numbers. Let's do a 2t plus 1, a 3 sine t, and a 3 cosine t. So I know it's a helix. Right, I want to know, so can you imagine we have got a object, right, zooming around in a helix, right, spiraling upwards. The velocity at time t will be 2, whatever 3 cosine t is, and negative 3 sine t. The acceleration will be the derivative of this guy, 0, negative 3 sine t, and this fella here is negative 3 cosine t. And the speed is the magnitude of the velocity vector. So it's a square root of 4 squared plus 3 cosine t squared plus negative 3 sine t squared. And that's 4. That's 9 cos squareds. And that's 9 sine squareds. Do you think that's the answer, or could we do better?
Do better.
Okay, what could you simplify it to?
Square root of 4 plus 9.
Are we getting used to seeing 9 cos squareds plus 9 squareds, or 3 sine squared 2x and plus 3 cos squared 2x? You know that sine squared plus cos squared thing that happens a lot in quite a few questions when sines and cosines are there. In this case here, then, your speed is root 13. So if you can imagine, what kind of helix do I actually have here? Oh, I have a helix that's going along the x-axis. So can you imagine there's a helix going this way? At any given point, its velocity is whatever this is. So that's a velocity vector. If it was this point here, it'd probably be pointing down that way somewhere. Its acceleration vector is this fella. And the speed, which is basically there. So if this was a weird kind of corkscrew roller coaster, at this point here, I'd be shooting off at my death, whatever that is. That's the vector. And I would be going at root 13 miles an hour. The acceleration vector is a little bit different to kind of figure out what it's telling me. Essentially, it's telling me how each of the components of x, y, and z, each of these velocity components, is going to change through time. So can you see in this case that the velocity is not going to change at all, right? It's going to stay put. The x component is going to be at 2. On the other hand, this fella here will change by that amount, and this fella here will change by that amount. So it's kind of telling you, as the thing turns, the velocity is going to change. So far, so good. Kind of plug and chug, right? You got formulas, things to do. I guess I should start picking questions that look more like the homework then. Ooh, good, that was a funny one. Didn't take me long to find a weird one. This is like question 3. The space curve of this moving object is 4 square root of 2t e to the 4t and e to the negative 4t. Question A is asking us to find the velocity vector. Okay, do you know that's just like 22t? If you differentiate it, don't you just get 4 root t? If you want to differentiate e to the 4t, you get e to the 4t times an extra 4. And if you want to differentiate that guy, you get this. Question B wants the acceleration. Well, if you differentiate a number, even one with square roots in it, it's still 0. And this guy, you get another 4. And this guy, you get another negative 4, which is why that answer is positive. So, I mean, you could probably do each one in what, less than a minute? At least this question. Well, the one that's probably going to be the messiest one is the speed, which is that guy. And it's going to be the square root of this fella squared plus this fella squared plus this thing squared. And it's not that writing that down is hard. What's going to be hard is making it pretty, right? Style points. If you've got something squared, you can square each part. So that's 16 and that's 2, so you'd get 32. Are you happy about 4 root 2 gets you 32? Now, if you square this guy, you get 16. And if you square this guy, you essentially double his power. If you square negative 4, you still get plus 16. And if you square the other power, you basically double it. And I am now going to rearrange this guy. Because I think we could make this pretty. Any ideas about what you might be able to do to make this pretty?
Perfect square.
Oh. Did you use the, if there's 3 things, it's probably a perfect square?
Yeah.
Will you remember that that's not a written in stone rule? It's just that if you see 3 things, it probably is. I want to emphasize that. Can you imagine that you may get a question that looks like that? I know it's got 3 things in it. Would you also agree it ain't a perfect square? Right. So you could quite easily get questions that have 3 things in them, but they are not perfect squares. But in this case, yes, it's got 3 things, but don't they also look like they kind of belong together? Right? They're not totally dissimilar from each other. Okay. Now, in order, big, middle, small. Positive power, number, negative power. This fella gets you 4e to the 4t. This fella gets you 4e to negative 8t. And yep, it works. Which means that we now have
negative 4t.
Thank you. We now have the answer, which is quite nice looking, isn't it? I'm not going to push this one because it's really not a big deal. But I guess if you were a perfectionist, you could probably pull out a common factor of 4. But yeah, 61.5 a dozen out. I think the main make it look nice has happened here, right? The style points has done its job. So be on the lookout. Be on the lookout when you're doing trig with sine squared plus cos squared, right? They can be nice, can't they? When you see 3 things, be on the lookout for a perfect square. Hopefully it is one, but you know, occasionally it's not. I'm picking up good vibes right now. Would you agree that compared to what we've been doing, it's just a whole load of differentiation going on, right? It's a whole load of calc 1. Okay, a little bit of messy, you know, square root stuff, you know, magnitude of vector with a little style point. Okay, that one went good. Okay, I'll try this one. I don't know why I don't know if this one is going to be pretty. It looks weird. Let's see if the one next to it's weirder. Yeah. It's a time issue. Which one do I want? Which one do I want? I want this one. I'm going to pick 5. It was between 4 and 5. They're different in their own ways, but I don't have time to do both. So this is a version of 5. I'm actually going to write it down the way it looks in the homework, because almost every question I do, I convert it into the the component form. It's e to the t, this guy. You can choose not to do this, but this is what I do. I don't like IJK notation. I make too many mistakes with IJK notation. Can you see that I've multiplied these guys by e to the t and then separated them out? Are you comfortable with this is actually this? Agreed? Now, to get the velocity vector, what I need to do, product rule, product rule, product rule. Would you agree that's a product rule? Would you agree that's almost the same, but a sin t is still a product rule? And would you agree this is a product rule? Now, if you wanted to do, and I'll just do one of them and then tell you the answer for the other two, which one of those 3 do you want me to do just to show you the product rule working? First, second, or third? Any particular preference? Okay, so we are going to do this guy. Let's call him y. Now, if you want to differentiate him with respect to t, it's f dash g plus f of g dashed. And normally in product rules, don't you just make the first guy f and the second guy g because it doesn't really matter? On the other hand, if you're doing integration by parts, right? Integration now by parts, doesn't it sometimes, it does matter who f and g are, right? So in this case, differentiate that, leave this guy alone, leave this guy alone and differentiate that. And you are going to get e to the t cosine t, take away sine t. So this guy here is e to the t cosine t, take away sine t. Check. This fella here is basically just going to have a sine t here. So what we're going to get with the second one, once you pull this out, you're going to get an e to the t, you're going to get a sine t, and plus a cosine t. And when you do the last one, you're going to get you're going to get an e to the t, and then you're going to get an f dash, so you're going to get 6 plus e6t. Okay. So the velocity vector is going to be this horrible mess. Really, I don't think I need to write any more down. I don't think I could, okay, I could pull it a 6, but that's not going to make any real difference. Now, I've decided to stop here because would you agree to get the acceleration vector, I just have to do some more product rules, but with different pieces, right? Product rule, product rule, product rule. The advantage of pulling out the e to the t as a common factor here is that it's more obviously just a single product rule. Otherwise, if I'd left it as 2 separate pieces, wouldn't end up having to do 2 separate product rules, and that seems a lot of work. Now, what I will try and do, because it's quite messy, is let's find the speed. So it's going to be the square root of this guy squared. plus this guy squared. Plus this guy squared. And I'm just hoping that that horribleness turns into something kind of nice. That's my wish. Right, you square this guy, you get e to the 2t, and I'm just going to call this guy that guy right now. And you're going to have e to the 2t. You're going to have this guy. And then you're going to have e to the 2t. And then you're going to have that guy, right? So I haven't really done that much. Okay, let's write down each piece and see what we get. The first piece looks like this. And what does that get me? If you FOIL this out, you're going to get a cos squared t, a -2 sine t cosine t, and you're going to get a plus sine squared t. Are you comfortable with the FOIL gets me that? Okay. Is there anything I can do to this before I move on to the next one?
Cosine squared plus sine squared. Convert to 1.
And it's not a lot, but I mean, every little bit helps. Would you agree? Every little bit makes it a little bit easier. Okay. The second one looks very similar, but it's a sine plus a cosine. And that's going to get me e to the 2t. And again, you're kind of trusting me here. You get that. And won't these two also get you 1? Are we comfortable with that one? Right, do the last one then. That's going to get you e to the 2t, 36, 72t, 36 t squared. Now, I'm going to take that guy, and that guy, and add them all up inside the square root. Whoa, that's going to be a lot. Here it goes. Can we just take e to the 2t, because it's a common factor for all three, and that way I just need to add this, this, and this together. That seems sensible. I'm using the fact that they all have an e to the 2t, so I just need to add what else they have. So this is the first guy. This is the second guy. And this is the last guy. Anything going on here that we can work with? Anything simplify? I can see something, can you?
-2 sine t cosine t cancels with the other one.
Right, so I get a 1 and a 1 and a 2. I guess that's 38 plus 72t plus 36t squared. And there's an e to the 2t. I'm now going to go and separate that out. And that's going to leave me with this guy. And I know that I've got 3 guys. Can you trust me? It's not a perfect square. Not every 3 guy is. That's, well, I was hoping for more than that, but at least it's half decent. You agree? It's not totally ugly. At least it's a lot nicer than it could have been. And That is the end of that bunch of questions. So if I give you a space curve r of t, you're comfortable about getting velocity, acceleration vector, and the one that's going to probably cost you the greatest amount of time, speed. Now, before we look at the second and final part of today, I want you to wind back to Calc 2. Can you remember getting a question in Calc 2 that said, oops, forget vectors, that the acceleration at time t was t cubed plus t, and the velocity at 1 was 7, and the question says, find the velocity function. Can you remember those working backwards questions? If you know the acceleration, what do you do to find the velocity?
Integrate.
Okay, so you would integrate t cubed plus t, and you would get 1/4 t to the 4. Well, can I make that 0 just to make my calculation easier? Plus a half t squared plus c. And what was this guy's job? Why were you told v of 0 was, in this case, 7?
To find c.
Right, now, because I made it 0, it comes out very easily, but it doesn't always have to be that guy. Are we cool with that process? That if you know the acceleration, you can work backwards by integration to get velocity. Well, let's do the exact same thing. This is question 6. Let's do the exact same thing. I'm going to tell you the acceleration vector. 8t sine t cosine of 2t. And I'm going to tell you that the velocity at 0 is the vector 1, 0, 0. And the question says, find the velocity vector using this information. So the velocity vector is the integral of the acceleration vector. And it's the integral of 8t sine t cosine 2t. And we know how to integrate, don't you? Just integrate 3 times. So add 1 to the power, divide by the new power. Remember to have your integration hat on, so that's negative cosine t. Integrating the cosine of 2t gets you the sine of 2t. Is that all it gets you?
1.5.
Yeah, easy to forget that guy. Now, technically speaking, isn't that plus an arbitrary constant vector c? So instead of me saying plus c1 plus c2 plus c3, can't I just say plus a unknown vector c? Now I know that the velocity vector at 0 is 4 lots in nothing squared, negative the cosine of nothing, and a half sine of nothing, nothing, right? And I know that that vector, right, at 0 has this fella added onto it. And I also know that it's 1, 0, 0. So let's see what that would look like. 0, negative 1, 0, plus c1, comma, c2, comma, c3 should equal that vector. Okay, let's match them up. 0 plus c1, negative 1 plus c2, and 0 plus c3 should be that fella. Well, if that's going to be 1, c1 has to be 1. If that's going to be 0, c2 will have to be 1. And if that's going to be 0, c3 has to be 0. I now know the full velocity vector. It's 4t squared plus 1. It's negative cosine t plus 1. And it's a half the sine of 2t plus nothing. Does that process make sense on how, if you're told the acceleration, you can find the velocity vector, provided you give me enough information? And the information is, tell me the acceleration vector and tell me the velocity at some given point t. So far, so good? Now, I now know my velocity vector, so I'm just rewriting it again. And I'm now going to find, shouldn't be a surprise, the accelerator, oops, not the acceleration, the position vector, right, the space curve guy. And we're told that its position at 0 is 0, 1, 0. So if finding the velocity vector, you integrate the acceleration vector, to find the position vector, shouldn't you integrate the velocity vector? Does that make sense? Integrate acceleration gives you velocity, integrate velocity gets you position. So in this case, it's going to be 4t squared plus 1 negative cosine, oops, well, yeah, it is, okay, that one. So I need to integrate each one separately. I feel I really didn't need that line, but it's too late now. Oh, power rule. Oh, darn it, that's 4/3 t cubed plus t. Oh, let's put the c1 here this time rather than as a vector. Right, this guy, if you integrate it, you get negative sine t. Integrate that guy, you get t, and call that guy c2. And this fella here, well, you get a negative, don't you? And you get a quarter as well. C3. So I've got the general answer to it. Now I need to find out what C1, 2, and 3 is, and we're using that. So the position at 0 is nothing cubed plus nothing, basically C1. Sine of nothing's nothing plus that guy, C2. Cosine of nothing is actually 1, so that's going to be negative a quarter plus C3. And we were told in this question that it was this fella. So you match them up, C1 has to be 0. If you match this fella up, C2 would be 1. If you match this fella up, C3 has to be positive a quarter. So the final answer is this guy plus 0. This middle guy plus 1. And this last guy, which is him, with a quarter. Okay, a little bit quick. Are you comfortable with the process? That if I give you the acceleration vector, you move backwards 1 to find the velocity. Once you've figured out exactly who the velocity v of t is, you can then work backwards once more to find the position vector rt. And as you can see, doesn't it involve, depending on what the processes are today, a whole load of integration, or earlier on today, a whole load of differentiation. Boring, don't want that one. I'm picking this one not because it's difficult. I'm just wanting to show you how it might look like in your homework, because I keep transferring them into how I like things to be for me. You're being asked in this question to find the velocity vector, and then after that, find the position vector. Have you noticed that the information is given in the IJK notation, which I personally, as you know, don't like? So this fella here is 5, 0, 8. And the velocity at 0 is 0, 0, 1. And the position at 0 is 1, 0, 0. If you go the way I tend to do these.
Wait, is it?
Right.
It's IJK, right?
IJK.
580 for the acceleration.
Yes, thank you. Well caught. Which shows you why I do not like IJK notation. Right, at least the integration is going to be quick, so I might as well do it since it's set up. To get to the velocity, can we just go straight into integrate here and not set up all the other bits? So wouldn't you get 5t plus c1, 8t plus c2, and 0t, so it's still 0, and you get c3. So I'll just write that again because it's a little bit messy. You get that guy, you get that guy, and you get that guy. And the velocity at 0 then is a whole load of nothings c1, a whole load of nothings c2, and a c3. And according to this, it should be 0, 0, 1. So that basically makes u0 and u0 and u1. So I now have the answer to the velocity vector. 5t plus nothing, 8t plus nothing, 0 plus c3 gets you 1. You can then move and do the acceleration. Again, I'll skip the middleman and go straight into the answer. You comfortable with the integral? Because it's basically just a whole load of power rules. And I know that the acceleration, I'm saying acceleration, darn it, my brain today. It's working backwards, it's the position vector. And the position vector at 0 is a whole load of nothings c1, a whole load of nothings c2, and a whole load of nothings c3, and it's meant to be 1, 0, 0. So that's 1, and these are zeros. And I squeezed that one in really quickly. 5 over 2t squared plus 1. Where are we? 4t squared plus nothing. Too late, I've written it. And t plus nothing. And we finished. Are we good with this guy? Okay, I get time for one last version of this, because that's the only two things you're going to be doing today. So since I have one last question to do you want a space curve turning into a velocity acceleration as my last example, or do you want me to do an acceleration becoming a velocity becoming a space curve? Which one do you want?
Acceleration, velocity, space curve.
I know you said it, but for some reason I couldn't catch it.
Acceleration to a space curve.
Okay, so acceleration becoming velocity becoming space curve, right? Okay, well, I'm going to make this one deliberately ugly, because if you can do the ugly ones right, the easy ones are baby. So not that that's ugly, but I want to put that in. I want to put that in because we haven't seen a square root. And I want to put that one in, because I don't think we've seen some ugly versions of that fella. Right, oh, there we go. And I do need some velocity at 0 and position at 0. And I'm going to make this guy 0, 0, 1, and I'm going to make this guy 1, 1, 1, right? There's no reason in the world why these should be 0. Couldn't you be told the velocity at 1 or 21? I'm pretty sure they're picking zeros because they make the calculations easy. So, power roll. How am I going to integrate the square root of t? What shall I do?
Make it into t to the power of half.
Okay. Which means it's going to be what? Add 1 to power, new power, and then make it look pretty. So that's where this came from. So 2/3 square root of t cubed. How am I going to do that, guy?
Integration by parts.
Okay. So, are you sure?
U sub?
Yeah. Can you see why a U sub works and why an integration by parts won't? Okay. So, make that t squared, differentiate, cross over, isolate. Can you trust me? You get a half e to the u, which becomes a half e to the t squared. And that makes this fella then a half e to the t squared. And if I got my plus c2 and I put my plus c3 and I'm looking at my watch, so I'm only going to turn it into velocity. Okay, if you use 0, 0, 1 here, 0, 0, 1, right? So you plug in 0, you get C1. You plug in 0 here, you get C2. You plug in 0 here, you get a half plus C3. And that should equal 0, 0, 1. And so basically, I know those are 0. And I know this guy here has to be a half. So it's going to be 1/3 t cubed plus t plus a half. 2/3 the square root of t cubed. Why did I say plus a half? It's 0. And that's 0. And it's the last guy who gets the plus a half. So, correct answer was that guy plus 0, that guy plus 0, the last guy plus a half. And if I had to, which I won't, to now get the acceleration and to have to integrate them, you're probably going to have a problem with a half e to the t squared. But since we're not going to do it, it won't matter. Whew. Okay, got 4 minutes to tidy up here. We all know what's happening on Monday. Test. We should all know, I hope, what topics are covered in the test. And I'm just loading up our classes thing, and I'll move over and we can see it. And darn it, it's gone away again. Ah, darn it, in space. I'm hitting buttons everywhere and don't know what I'm hitting. There we go. So this Sunday, you have 13, 1, 2, 3, and 4 to do. Basically, motions in space have been reduced to only include what we've done today, right? So your homework doesn't have some of the other stuff. I'll tag that on after the test. I'll call that part B or something when we do it. There are 4 sections here, so you're going to get a question from each section. Right, so the 4 questions going to be in your test, you know that. I think you just get used to me by now. Are you not? You know what you have to do, you turn up. The Zoom thing will be there. You upload it when you're finished. Don't talk to anybody about the test. Don't go, doing things that you shouldn't be doing. And that's pretty much it. Any questions about the test, or you kind of knew what was going to happen anyway? Okay, right. If test time doesn't fit, you contact me and we'll move it around to suit your schedule. So it's not a biggie if something happening on Monday that interferes with your ability to do your test at the usual time. As far as I'm concerned, that's us finished. So say hi and then bye-bye.
Have a good one.
You too. You're not allowed a good weekend. You are studying and getting your homework because you have a test on Monday. So you are not allowed a good weekend, but I am. Okay? That doesn't sound very fair, does it? Yeah, life's not fair, so what are you going to do about it?
I have a question about.
Sure, question.
So I have a chemistry final exam. I think I have to look and see what day it is, but I know it's from 10 to noon. If that does happen to interrupt the
You
final,
just shoot me an email saying I'm free this time slot,
okay.
and that's when you'll do it. All that'll happen is that when you go to WebAssign, there'll be a test. It'll probably have your name on it, so you know it's yours, and you'll do it then.
All right, I'll double check and see if it's the same day or not. But
Okay, no problem. Any other questions? It could be homework now. Nothing? Douglas?
Just watching.
Yes, watching. I think today went pretty smoothly. You could either, I know it was a lot of stuff to do, but it wasn't particularly difficult stuff to do. It was more time consuming than anything. Right? Differentiate. Okay, ugly square root. And then integrate, different kind of problem. Ivan, you got a question?
I do. It's
Okay.
on the homework 13.2 and question 14. I can't quite remember what it was asking, but I think it was where do the space curves intersect?
I remember doing that darn one. Did we do that yesterday? Was that with someone else?
I can't remember, but when I would match up the points, everything would turn to zero, and they would,
that does
stuff
sound
would
like
disappear.
it's right. That sounds like it's different. Okay, let me.
I know you
go
talked about it, but I couldn't remember what that meant.
Not a problem. I got it now. Right.
I think the one we did the other day was on 13.1.
Okay.
So this one, there's a second part where it asks for the angle.
Oh, is that asking for an angle one? Ivan, is 13.2 asking for an angle?
I think it does. I think it asks for the intersection and then the angle that it intersects. I don't
Okay.
have it up right now.
Right, that's okay. I'm looking it up right now as we speak. It looks like it's the only one you had problem. Well, no, you had problem with. Anyway, don't matter. 14 found it. Click. Okay, so this is the information. I'll be transferring it to the white screen so we can see it. And we'll see what we get here. So I got a space curve R1 of t, and it's equal to t, 2 take away t, and 15 plus t squared. And this time they did what they should have done in that other question. Do you notice they made the other one an S, which is helpful. And it's going to be a 5 take away S, S take away 3, and an S squared. So this should be the exact question you've got, because I looked in to your particular name. And so this is the guy. And they want to know the point where it intersects and then the angle that they intersect at. Okay. That's the questions. Agreed? Right. I'm going to do the second part first because it's the easy one. If you look at the first one, the R1 of t, the coefficients. Oh, darn it. Take that back. That's squared. If that hadn't been squared, I was going to tell you a shortcut, but it isn't, so forget what I just said. And we'll continue with doing where they intersect first, because I do now need to know those. If you match the x's together, you get that. And that's equation 1. And if you match the y's together, you get that. And if you match the z's together, you get that. So I'm pretty sure you did that, right? And since this one is already written as a t equals, I'm assuming that you plugged it in here and everybody disappeared and you thought, what the heck, right? Well, let's not plug it into 2, because that could happen, and it did. I'm going to plug it into 3. So instead of 15 plus t squared equals s squared, I'm now going to have 15 plus 5 take away s squared equals s squared. Do you notice I have to make my s's look not like 5s? So if you're wondering why my s's look funny, it's so they don't look like 5s.
I have to make my z's not look like 2s.
Yeah, I put strokes through my z's to do that as well. Yeah, it's quite common. 25 take away 10s plus s squared is equal to s squared. That's 35 take away 10s, because they cancel and you get 0. You happy with that? Now, can you see in this case, you can actually solve it, right? There's a variable left over that is solvable. And so if I add 10s to both sides, and then I divide by 10, I get 5, just 7 halves. Don't like that answer, but do not like that answer at all. I mean, I like the fact it's a number. I just don't like the fact that it's 7 halves. So let me check that I didn't write some down wrong. T, 5 minus s, agreed. 2 take away t, yep, equals s take away 3, check. 15 plus t squared, yeah, and t squared. Okay, so I should be able to find out where these guys intersect. Well, if t is 5 take away s, and s is 7 halves, that makes t 3 halves. That's fine. So if everything works out correct, and I'm a little bit worried about my math, so something just doesn't feel right. I can see it. Does anybody see what I did wrong.
Oh, yes.
40. 44. Now I'm happy. So T is 5 take away S. So T is equal to 5 take away 4. T equals 1. Now, actually, I didn't need to do that. But if I plug T equals 1 in here, I'll get the coordinates of intersection. And if I plug S equals 4 into here, I will get the coordinates of intersection. And it's a way for me to check that I've done it right. Because if I'd used this guy, you would have noticed that the answers weren't the same. And they were I was kind of doing it in my head and I'm saying, nah, these don't look like they're going to be the same. So let's check them out and see what we have, right? You do the first one with the T, you get 1, 2 take away 1, and 15 plus 1 squared. If you then do it with the S guy, that's 2, what do you get? Nobody noticed it's 4. 5 take away 4 is 1. 4 take away 3 is 1. And 4 squared is 16. It matches. Hey, so I know I've done it right. So that's question A done. Coordinates of the intersection. Now, can you imagine that that point there is 1, 1, 16? And we have an R1 going this way. And we have an R2 going this way, right? And we want to know the angle theta. I need to know the direction of this curve at t equals 1. So here's my space curve. And I need to know what direction it's going. That means I need to find the derivative at 1. So that's 1 minus 1, 2t. And its direction at 1 is the vector 1, negative 1, 2. So I'll call that V1, meaning the direction of this line. Now, if you go for the second guy, oops, this is an S here, and he happens to be 5 take away S, S take away 3, and S squared. If I find his derivative, I get negative 1, 1, and 2S. And I will find out what he is like when S is 4, which is negative 1, 1, and 8. And I'm going to call this guy V2. So can you imagine that this line here has direction V1, and this line here has direction V2? Can we just use dot product? The cosine of the angle between them is the dot product of the two direction vectors divided by the magnitude of those two direction vectors. And this guy here is V1, and this guy here is V2. So let's see what we get. 1 times negative 1 added to negative 1 times 1 added to 2 times 8, which is 16. So that goes in the top. The magnitude is 4, 5, 6, square root of 6. The magnitude is 64, 65, 66. The top ends up being 14, and the bottom ends up being that guy. And somewhere I've got a calculator. The inverse cosine of that guy is theta. Inverse cosine 14 divided by, put a bracket around it because there's two of the damn things, a square root of 6 times a square root of 66. And I get the answer 45 degrees to the nearest whole number, because that's all they want. And that's actually the right answer, so I must have done it right. So you only find the angle that two vectors, two space curves intersect. Find the angle between their derivative vectors at whatever point, you know, in this case, t is 1 and s is 4. Are you okay with that question now?
Yeah, thank you. That helps a lot.
Okay. Have we got anything else, guys, or are we going to call this good? Okay. Have fun this weekend learning some cool stuff, right? And I shall see you on Monday for the test.
Thank
Bye-bye.
you. Have a good weekend.
You too.
Thank you.
Bye.